Get some half angle identity problems. Actually, I'll probably just do one. They get kind of lengthy. And so what you have to do basically when you're working these half identity problems is you have to decide which one to use. You're given three identities. You have sine is equal to, cosine is equal to, or tangent is equal to. And so I'm going to go ahead and work this problem. We're given that tangent theta is equal to negative root 2 over 2. It tells us that theta is in quadrant 4, and then it tells us that, or it asks us, cosine theta halves is equal to what? And so my cosine theta halves, the identity that I'm given, cosine theta halves is equal to plus or minus square root 1 plus cosine theta over 2. And so if I want to find what cosine theta halves is, I need to know what cosine theta is so that I can plug that in there. I'm given tangent theta, and I'm told that theta is in quadrant 4. And so if I make myself a quadrant plane here, or coordinate plane, where this is my x and this is my y, I'm in quadrant 4, so I make this reference triangle. This is a right angle, of course. Now I'm given tangent theta, and if you recall from SOHCAHTOA, tangent is equal to opposite over adjacent. So if this is theta here, tangent is equal to opposite over adjacent. So in this case, then I know that the opposite side, this would be opposite over adjacent, so the opposite side would be root 2, and the adjacent side would be 2. And you should be able to see that since this x value here is positive on the coordinate plane, and this value here represents the y value, and it's negative on the coordinate plane, so that is the value that receives the negative sign from this fraction. Remember, when you have a fraction that's negative, you know either the numerator or the denominator is negative. So this is how I get this, and if I want to know what cosine is, or cosine theta, according to SOHCAHTOA, is equal to the adjacent side over the hypotenuse. And so I need to know what the hypotenuse is here. And how do I do that? Well, I use a Pythagorean theorem because I have a right triangle here and I've given two sides. So I have 2 squared plus negative root 2 squared is equal to my hypotenuse squared, so I'll call that h squared. 4 plus negative root 2 squared is 2 equals h squared. Because see, root 2 times root 2 is just 2, and a negative times a negative is positive. So this becomes 6 is equal to h squared, and h is equal to plus or minus root 6. Well, the hypotenuse in these reference triangles are always positive, so h, my hypotenuse here, is going to be positive root 6. That tells me that my cosine theta, is equal to adjacent over the hypotenuse, and I can simplify this. Don't want a radical on bottom, so we multiply this by something equivalent to 1, which is root 6 over root 6. What you do is you take your radical that you don't want on bottom and you make a fraction out of it that's equivalent to 1, and anything over itself is 1. So then top times top, 2 root 6 over root 6 times root 6 is 6, which reduces to root 6 over 3. So cosine theta is root 6 over 3. Now I can plug it into my little identity up here, just plus or minus. So cosine theta halves is equal to plus or minus 1 plus cosine theta, which is root 6 over 3 over 2. And then simplify this fraction up in here. I'm just going to take it over here in a different color. So I've got, looking at the numerator, 1 plus root 6 over 3 becomes 3 over 3 plus root 6 over 3, because I need to have a common denominator and have to make one a fraction with a denominator of 3, so it's 3 over 3. Anytime you're doing a fraction, adding or subtracting fractions, or you just need a fraction and the number's 1 and you need that common denominator, you just pick that denominator that you need, and then that's your 3 over 3. It's that denominator over that denominator. And this gives me 3 plus root 3 rather, over 3. And so this becomes plus or minus square root 3 plus root 3 over 3 over 2. Which basically what happens here is a couple of ways I can look at this. I'm dividing it by 2, dividing this, what I call an ugly looking fraction here, by 2, or I'm going to multiply it by half. So what I really have here is 3 plus root 3 over 3 times half, which gives me 3 plus root 3 over 6. Because 1 times this top here is just that top there. And so I get plus or minus square root 3 plus root 3 over 6, and that's as far as that simplifies. So cosine theta halves is equal to this, but we have to determine, is it the positive or the negative? We have to decide which sign. So I'll go back to this information that I'm given that theta is in quadrant 4. And if theta is in quadrant 4, that means theta is either between 360 degrees and 270 degrees. So if it's 360, if I divide that by 2, that puts me over here at 180. So that's the max. If I was at my max, I would be over here at my max if I halved that. And here my max is 270. If I half that, I'm at 135, which both of these, well, 180 is really on the x-axis, but 135 is up here somewhere. And so what it seems to be is that theta halves is going to be up here in quadrant 2. So in other words, what I'm doing is I'm taking the idea that theta is in quadrant 4 and what those values could be from 270 to 360. It would actually be a little bit above 271, or a little bit above 270, or a little bit below 360. So when I half this little bit below 360, it put me in quadrant 2. So theta is in quadrant 2, and cosine in quadrant 2, if you recall, all students take calculus in quadrant 2, only sign and its reciprocal is positive in quadrant 2. Therefore, cosine is negative in quadrant 2. And so my answer, cosine theta halves, is equal to negative root 3 plus root 3 over 6.